Back with Learning with Mr. Neff. I can solve one variable inequalities and then graph them really good. So that's what we're going to focus on here. I got 4 examples that I want to show you here as to how to do this. First one, you have x plus 8 is greater than 4, and we want to solve here. So we want to find all possible solutions for this, and then we're going to graph that. All right, now think of some of these solutions. For instance, 20 is a solution, right? 20 plus 8 is greater than 4. 25 is. 30 is, right? 15 is. These are all solutions. So we want to solve, and so we're going to show all the solutions. Well, how do we do this? We solve the inequality first. And so what we do is picture what you would do. People are always confused about this until they look right here. Not always, but what do we see right here? X plus 8 equals 4. What would you do in that particular instance? You would subtract 8 on both sides. Guess what we're going to do right here? Subtract 8 on both sides. Alright, 8 minus 8. So over here, I always show it on both sides. I make sure people understand that this part right there is going to disappear. Alright, so I did it on that side. It's gone. That plus sign is gone. It's all gone. Okay, it's gone. Alright, so x is greater than negative 4. How do we graph that now? So we're going to put all the numbers greater than 4, negative 4 would be a solution to that inequality, I should say, not an equation, inequality. And so let's go ahead and get the marker here, and let's put our dot at negative 4 if I can. Open dot, clearly an open dot, and it says greater than negative 4. So I'm going to shade this way here. Alright, and the other thing I want to do here is use a test point to prove you that this is right. So I want to go back to the original here. Let's just pick a number on here. Alright, like 7 right here. 7. You see 7 right here? Okay, just so you see it again, right? Did we shade the right way? So if we shade the right way, when I put 7 in here, right, I got the little red blob I moved there so I can see 7. Alright, do I need to write it in here? Is this true? Is 7 plus 8 greater than 4? Of course it is. It's 15. Right? So in the original, I checked it and I saw that I shaded the right way. Now let me show you even some more. Negative 6. If I put that in, is negative 6, mental math, greater than 4? Negative 6 is plus 8 is 2. No, that's not greater than 4. So in that particular equation there, I was right in not shading over this way. All right, and so that's our solution, is x is all numbers greater than but not equal to negative 4. All right, problem 2 with Learning with Mr. Neff. Thank you. Yes, I know this is exciting. All right, I try and be as interesting as I can with mathematics. Apologize if I bore you. But anyway, here we go. So now here's a similar problem. Again, picture if this was an equal sign. If this was negative 7 plus x equals negative 8, what are you going to do? Yeah, that's right. I'm talking to my fictitious classroom here that no one is here. I'm going to add 7. Some of you say minus a negative 7 or subtract negative 7, but the easier way to say is just add 7 on both sides. All right, and so on the left it goes bye-bye, and on the right you have, right, that's bye-bye, you have negative 1. So x is all numbers greater than or equal to negative 1. So now I use my close dot, and I'm going to shade to the right all the way. And so my solution is all numbers greater than or equal to negative 1. So 0 works, right? If I go back, look at the original equation here, move my blob here, negative 7 plus 0, all right, is that greater than negative 8? So what I'm saying, let's go over here. Oh. So in my check here to see, is negative 7 plus 0, oh, is that a 7? Negative 7 plus 0, is that greater than negative 8? Okay. Or equal to. Of course, I got that extra line I got to put in there. So, or equal to negative 8. Yes, it is. You say, no, it's not. All right, look at a number line. Negative 7 Is that greater than negative 8? Sure. More right it is, the greater it is. So yes, that is a true statement, and therefore that's done correctly. All right, let's look at now the multiplication division. This one gives people a little more trouble here. When I divide by a positive or negative, there's something that happens here. When I divide by negative, I should say, in this particular instance. Negative 5x is greater than 25. Now you figured out, okay, I just divide by negative 5. That is correct. I divide both sides by negative 5. And so on the left side, right, whatever wants to use the highlights to show it, that's gone though. It's gone. And so you're left with 1x. That's what we want. And then you got negative 5. But it's so important to realize what happens here. Notice I switch the sign. Without going into great detail, I have to flip the sign. When I multiply or divide both sides by a negative, being the opposite is really what that is. The opposite of 5 is going to cause everything to flip in this problem. And so x is less than negative 5. Do you see how the sign changed over here? Do you see how the sign changed over here? This was negative, now it's positive. This was positive, now it's negative. And this was a greater than, now it's a less than. And so my solution then is all numbers less than negative 5. Open dot at negative 5, shading to the left. And let's go ahead and do the check here now. So let's pick, how about negative 9? Clearly over here, negative 9. Is that true? Then negative 5 times negative 9, looks like an x here, times negative 9. Is that greater than 25? Well, I get, what, 45. And then, yes, that's greater than 25. Therefore, I shaded the correct way. All right. And one more, just so we see it. A lot of times people get confused. This is my division sign. X divided by 4 is greater than negative 2. What am I going to do here? It's division. So right, yes. And you're telling me correctly, I hope, from your computer screen as you look at this. Times by 4 on both sides. And so by, then over here, at 4, basically 4 over 4, or 1. 1x is left. And over here, what's left? Or what? Negative 8. So x is greater than or equal to negative 8. So here we have an open dot at negative 8. And then I am shading to the, which way? Right? Okay, so, and we can pick a test point. 0 is always a good one. 0 divided by 4, is that greater than negative 2? Of course, 0 is greater than negative 2. So we know that that is the right way. We can also, just to show you again, if we're wanting this now what about negative 12? Negative 12 divided by 4, if I just show you, so that's not shaded. So negative 12 divided by 4 is negative 3, and that's not greater than negative 2. Therefore, that's why we didn't shade it. Okay? Well, that's all we have time for today on Learning with Mr. Neff. It's been great having you tune in with me, and I hope you have a great day. Bye, y'all. I don't know where that southern guy came from, just at the last second. Sorry about that, y'all. All right, I'm done. I promise.